It is a sample question from exam paper. As you see on the sketch, these two boxes, one of 5 kilograms mass and the other one of 2 kilograms mass, are being moved on the rough surface to the right. Note, once the statement tells you about rough or smooth surface, you must know that rough surface means that there is the friction in between. But if it tells you about smooth surface, that means there is no friction in between, even if it can be any friction, but it is ignored as it is so tiny. Next thing they mention is that these boxes are moved with a constant speed of 2 meters per second to the right. This constant speed tells us that the acceleration is 0. So, first thing first. On 2.1, we are being asked to state Newton's first law of motion in words. What would you say? Well, on this statement, we are told about constant speed. So, about this scenario, I can say, these boxes will remain in motion of this constant speed, unless there is any of unbalanced force act on them. I think now you are retrieving the general statement of this law. It is written as so. We are done with question 2.1. On 2.2, we are being asked to draw a free body diagram for the box Q, that is this 2 kilograms mass box. They are targeting all forces acting on this box Q on this question. Draw and label them as so. There is the force here pulling right, that is tension force. There is the force here pulling up, that is normal force. There is a force here pulling backwards, that is frictional force, and also there is a force here pulling downwards, that is weight force, which is given by mass times gravity. We are done with question 2.2. Now, we are on 2.3. On here, there is an additional information to the statement. It is stated that this box Q is experiencing frictional force of 3 newtons, and this box P experiences the frictional force of 5 newtons on the contact of surface and the box. And we are required to calculate the magnitude of this F, which is an applied force. If we may strip off only box P, we see that there is the tension of the string which the opposing the force F. And also we have this 5 newtons, that is the frictional force experienced by this box P, and also on this applied force, there is this 30 degrees which is an angle between horizontal and this force F. There is the horizontal component on here which is F cos 30 degree, there might be vertical component also, but let us ignore it for now as we are talking about horizontal motion. Note, this F cos 30 degree is the force to right while being opposed by backward forces, that is frictional force and this tension force. We say, F net equals mass times acceleration. Remember that acceleration is 0, which makes this part of the formula to be 0. So, F net equals F cos 30 degree minus tension force minus frictional force. So, we take all this and equate with 0 like so. Remember, this negative means that they are opposing the motion to left. Now let us write it like so. On this equation, we have two unknowns, that is tension and this force F we are to find. Let us quickly find tension first. This tension we are to find. We will find it by using box Q only. So, on box Q, the tension is the pulling force to the right and is being opposed by this frictional force of 3 newtons. It is F net equals mass times acceleration. So, this F net on box Q is equal to tension to right, then minus frictional force to the left, all equals 0. This frictional force is 3. Now, this give us the tension force to be 3 newtons as well. Then, we go back to this equation and substitute as so. All these gives us this force F to be 9.238 newtons. I thank you all for your patience so far to the end. If you like such video, please support our YouTube channel by subscribing to it. So as we are posting more videos every week, you will be the first to be notified. Just click below, it will take you to our channel. Thank you.